I know that looks weird. Oops. One plus I think that's it. Whoa, shit. That's crazy, right? I mean, that's pretty cool looking. Wouldn't you say? That's kind of weird. It's abstract art. Now, did I type that in right? Yeah, it looks like I typed. So let's pick a value. Okay, let's go back to our work. And in order for us to figure out a tangent line, what do we have to know? I mean, go back, look at your answer down here. What do you have to know in order to figure out the slope of a tangent line? Can I give you just the x value? No, I have to give you the x and the y, right? X and the y. So I would have to actually go to my original problem way up here, right? This, and figure out if I can find an x and a y that works, that lives on that graph. I might be able to tell by here. It looks like, can someone tell me a point that looks like it lives on that graph? 0, 1. How about 0, -1? Yeah? Let's try 0, 1, okay? So what does it look like the slope of the tangent line is going to be? Look at this right here. 0, 1's right here, right? If I take the slope of the tangent line, it looks like it's horizontal, doesn't it? So the slope looks like it should be 0. Let's see if our answer corresponds to that. So at the point 0, 1, that means 0 for x and y equals 1 for 1 is y. Plug it in and what would we get? Y prime equals y, which is 1, times cosine of 0 times 1 plus y, which is 1, times sine of 0 all over cosine of 0 minus 0 times cosine of 0 times 1. All right, so let's see. What's cosine 0? 1. So here's 0, right? Cosine of 0 is 1. What's 1 times 1? 1. So we get 1. And then plus 0 over 1 minus 0, which is 1. That doesn't look right, does it? Does that look right? It's saying that the slope of tangent line there is 1. I don't like that. Do you? Oh, whoa, whoa, where'd that go? Let me do something here. It might be because I used the double. Let me see if that changes things. Where did my graph go? Oh, there we go. Okay. It's because I used the double X. I apologize. That's the way the computer program showed it, with double variables like that. So, yeah, that's still cool though, isn't it? Does it look like the slope of tangent line there is 1 now? Yeah. So you see how, I was using my answer to kind of confirm that we were on the right track and we weren't. Now we are. That's definitely not a function, right, when you look at that? But we found the slope of the tangent line. All right. Any other requests? 13? Okay, 13 is a good one. Square root xy equals 1 plus x squared y. Same instructions. Find dy dx. So I'm going to come in here with my implicit differentiation now. On the left side, what rule am I going to have to use for the left side of this equation? Chain rule, because I have square root of junk, right? But in the junk, what do I have? The junk is a what? Product rule right down there, isn't it? So what is the derivative of the square root of junk? 1 over 2 square root of junk, right? That's the derivative of the square root of junk. Chain rule now says times what? The derivative of the junk. What's the derivative of the junk? 1 times y plus y prime x. Are y'all getting that? Okay. Are we done on the left side? Yes. Okay, right side. Derivative of 1? 0. Okay, what do we have happening there? X squared y. What is the rule we're going to have to use here? Just product, right? Just product. What's the derivative of x squared? 2x times y plus y prime times x squared. So there's your product rule. Now I'm not going to solve for y prime. Is that okay, or is that the reason this was asked? It's okay? That's all right? What would I have to do, though, before I could start getting y primes by themselves? Distribute here and here. I have to break that y prime out of that parentheses, right? And that's the only way to do it. Okay. So I'm going to stop here. Before someone asks another one, let me give you one. No, you would have to solve for y prime. Do you want me to solve for y prime? Yes? Okay. So when I distribute through here, I'll get y over 2 root xy. That's that first distribution right there. That's just a y on top. And then the next one will be plus a y prime x on top of 2 root xy equals 2xy plus y prime x squared. Now I'm still going to do the same thing, all right? I'm going to move all my y primes to one side. So here's my y primes. Get those on the left side. Everything else to the right. You could do it the other way around if you want to. I mean, you can move everything to the right, all the y primes to the right, and everything else to the left. That's just the way I'm choosing to do it. So it becomes a negative y prime x squared equals 2xy minus y over 2 root xy. Now what? Unless there's a question. Any questions? Say again? Are you asking what are we going to do from this step? Our goal is to get all y primes on the left, right? Okay, so we have all our y primes. Here they are. Y prime is here. Y prime is here. Since y prime appears in both of those, we can factor it out. So I'm going to factor out y prime and be left with, it's going to be kind of ugly, but, you know, less is life, right? So I haven't changed the right side. All I did was pull the y prime out, right? Now to get y prime by itself, I divide both sides by everything in the parentheses on the left side. So it's going to look kind of ugly, but we should welcome ugly now with open arms. Now, I'm almost sure the book won't have it like that as a final answer. They probably took this complex fraction and simplified it.
At the beginning, do you care if we change the root xy to xy to 1/2?
Nope. Nope. Not at all. They probably did this. They probably multiplied the top and bottom by 2 root xy and distributed through like this. And the reason why is because it will cancel those fractions. So that first multiplication, meaning if I go here to here, that's going to give me 4, right? 4 xy times root xy. Then minus what? Y. All over what? X minus x squared, 2x squared root xy. Is that what the book has? It does? Okay. Yeah. So that's all they did. So if you got to this point here in blue highlighted, you got to that on the test. I mean, that's like 9 out of 10 points right there. I'm not going to, it's not wrong. It's just not pretty. But it's not wrong. Well, I'd argue that's not very pretty either. But okay. You good? All right. Now, I wanted to make one up. Something that would be more similar to like what I would ask on a test, all right? Sine, oh, you know what? Hold on. Yeah, I guess I'll do this. Sine x plus y plus secant x y cubed plus y equals x squared y to the 5th. Now, in a problem like this, I would probably tell you on the test, just find the derivative. Don't solve for y prime. Okay? So just do the first step of differentiation, just so I make sure you can do a derivative. All right, what do we have happening on the left side? Okay, here is going to be a chain, right? Sign of junk. What about the junk? It's a sum, right? So you just take the derivative of each one individually, don't you? So there's no like product or crazy rule there. What about on the secant? Chain, secant of junk. But inside secant, what do you have happening? Product there and sum, right? Okay? And then on the right side, it's just what? Product. All right, so let's see how this is going to happen. Let's start with the sign. What's sign of junk? Derivative of sign of junk. Cosine junk. Chain rule says now times the derivative of what's inside. Careful. 1 plus y prime. That's it. Because it's a sum, right? All you have to do is take the derivative of each one. But it's because it's a sum and not a product. You follow? Okay, are we done with the sine one? Yes? Okay. Plus, all right, be careful here. What's the derivative of secant of junk? This always gets people. Secant x tangent x, but it's secant of junk. So the derivative is secant junk tan junk. It's secant junk tangent junk. It's not secant x tangent x. And that's what a lot of students always put. Secant x tangent x.